Hey guys, in this tutorial I will be explaining the concept of edit distance and see various methods to solve this question. So first I will explain you how to do this pictorially, and after that we will jump to the code. So let's start with this. So suppose if we have two strings, that is RAM and second string is MAR. So what are the minimum number of changes we need to do in this first string to convert that into the second string? That means the changes which we are allowed to do is either we can replace any character from any other character to convert this into this text. Second possibility we have is to insertion. That means we can insert any character in between at the end or at the starting to convert this into this string. Third, we have deletion. So these are the three changes which we have allowed to do. Okay, so what we're gonna do now is first I will explain you the recursive method of solving this question. So first indexing of this string is done. Now let's jump to the recursive method of solving this question. Okay, so we have our pointer pointing to this end of the string. So 2 here represent that in the first string our pointer is at location 2 and in the second string our pointer is at location 2. Okay, so here we have three possibilities. So if we take the possibility of insertion, that means the second pointer or the first pointer will remain as it is. The second pointer will move to this memory location. So this is the case of insertion. If we do deletion, then our first pointer will move one back and our second pointer will remain as it is. And if we do replace, then our first pointer and the second pointer both will move one back to this memory location. Okay, same like that, at every node there are three possibilities. In this possibilities, if we consider the insertion, then we have 2 0. If we consider the deletion, then we have 1 1. If we consider the replacement, then we have 1 0. So as we can see that there is the same value which is computed more than once. There is a repeated value which is computed more than once. Okay, let's expand this. In the case of insertion, it will move to 1 1. In case of deletion, the pointers will move to 0 2, and in case of replacement, the pointer will move to 0 1. So as we can see here also 1 1 is still repeating, and as we can see 0 0 is also repeating, and so on. So by using this method, recursive method, what we gonna find it, at each point we have three possibilities. Each point we have three possibilities, and so on. So this will cost us to exponential time complexity, and we know that this is the costlier operation we have. So what we're gonna do is after that we will jump to DP version of this code. Okay, so why we need DP? Because as we can see, there are repeating substructures which needs to be computed again and again. So for narrow down the task, or for not computing this substructures again and again, what we're gonna do is at the first time when this value is computed, we store them in some kind of array or matrix, so that next whenever we need this value, we directly fetch it from this matrix and we do not need to compute this value again. So now let's jump to the coding section of this recursive method. So now look at the code of recursive function. Here we have passed our first string, second string, the last pointer of the first string, and the last pointer of the second string. That means if we have two string, that is ram and mar, then we are passing this pointer, that is fpos, and we are passing this pointer, that is spos. Now before going into anything, we have to handle the base cases of this recursive function. So whenever this pointer jumps down to beyond 0, then what we need to do is, the only thing which we are left is inserting that many elements which are present up to that s pointer. That means we have to make these many changes in our edit distance. Okay, now the second base case is when our second pointer jumps beyond 0, then the only thing which we are left is deleting these many characters up to that f position. So that many changes we need to require. So in this case we need to insert, in this case we need to delete. So effectively that many changes are required. Okay, now after that, if at any point of time our both the characters are equal or same, then what we need to do is we simply call this function again with our pointed shifting 1 back, because that values we did not need to compare, because both are same and we require 0 changes to convert this character into this character. Okay, so this is that case. Second is, if we have ram and mar, second thing we need to do is we recursively call this, or we can do at any point of time. Let's say if we have m and r here, so the first thing is we move one pointer back and the second pointer as it is. So this is the case where we have done the deletion. That means this point character is not equal to this character. The first possibility we can do is delete this character and move our first pointer 1 back. Okay, so this is that case of deletion. Second thing is insertion. So at any point of time, if we have ram and mar, if this character is not equal to this character, so what we need to do is we need to insert this character. Okay, so inserting this character, that means we insert this character here, and after that we shifted this memory location or this pointer 1 back. That is, we are shifting the second pointer, but we are keeping the first pointer as it is. Okay, so this is the case of insertion. Now third thing is replacement. We have ram and mar. So what we can do is, if this character is not equal to this character, we simply replace this character with r and shift our both pointer 1 back. So this is that case in which we are shifting both the pointers 1 back. So at any point of time, roughly we need to call 3 functions, that is 3 functions. So its complexity will be exponential, so it will be very slow in terms of speed. So let's say if I am passing 2 string from the main function, then how much time it will take to execute this 3 things. Okay, so let's say our first string is this and the second string is this string is of length roughly around 10 to 14. So let's see how much time it will take to execute this. So before doing that, let's compile this code too, and for running it, as I said, it will take time this string is very small. Instead of that, it is taking too much time. If we take bigger string, then it will take very much time, because it's exponential. See, 10, that means minimum 10 changes we need to required to be done in this string to convert this string into second string. The changes allowed are insertion, deletion and replacement. That keep in mind. Okay, now we will move to the second approach, that is the dynamic approach, which is the more effective approach of solving this question, because this is giving a time complexity of exponential, so it's of no use of going by recursive approach. So let's discuss the dynamic approach now. So earlier we see that it is taking exponential time, so without going into exponential time, let's discuss the dynamic approach of solving this question, that is by using the memoization. Let's say we have two string, that is RAM and MAR. So we need to find the minimum number of changes that is required to convert first string into second string. Let index this table. So the first question arises is why we are using db, because we see that we already saw that the code or the function is called many times, as we see that one value is computed more than twice or thrice. So let's show that value in some pre-computed table, so that whenever we need that value again, we simply see the table and got that value. Okay. Now what this index represents is, this represents that currently we don't have any character in this particular second string, and this character represent we don't have any character in this particular string, and so on. We have one character, two character and three character and so on. So let's start matching character one by one. Before doing that, we have to make sure that we fulfill our base conditions. That means if we have the first string which is empty, that does not contain anything, then the minimum number of changes required to convert this string into this string is, if this is 0, then simply we does not require any change. If this is 1, we need to insert one character into first string. If this is 2, we need to insert one character also, that is 2 characters, 3 characters and so on. So this is the base cases which we need to fulfill. Okay, now when it comes down to this memory location, now R and M both are different, the characters are not same. Okay, so in this case M is not equal to R. So what we gonna do is, we have three possibilities. First one is, either we insert, that means if we do the insertion, then we are at here. If we do deletion, then we are at here, and if we do replacement, then we are at here. Okay, so we have three choices. Minimum one changes we need to require. Now either it could be I minus 1j, or it could be ij minus 1, or it could be I minus 1 j minus 1. So these three possibilities we have for insertion, deletion and replacement. Okay, so we have here is minimum of 1 plus 0, 1 and 1, that is 1 only. So minimum change required is 1 and so on. Now let's fill out this memory location. Here M is not equal to A, so in this case what we're gonna do is simply 1 plus minimum of all three adjacent values. Okay, so that is 1 only. So here we have 2, and same like that, if we want to fill this memory location, then we have 1 plus minimum of 2, 2 and 3, that is 2, so effectively 3 and so on. If we fill all these memory blocks of our DP, then effectively at the end our answer will be contained in this block. That is, if we have a string of length 3 and a string of length 3, then whatever is the minimum number of changes required, we are present at here. Okay, so let's now quickly fill out these values. A and R is not equal, so we simply take 1 plus minimum of this, that is 2. A and R equals, so simply take the diagonal value, that means 1. Okay, just remember one thing, in case when both are equal, then we are simply taking the diagonal values. Okay, because these characters we did not need to consider, so simply this is the thing which we need to put here. So this both are not equal, so we are placing 2. So R and A is not equal, R and R is equal, so simply what we are doing is we are putting the diagonal value, that is 2. R and A is not equal, so we are taking 1 plus minimum of all these 3 value, that is 2. M and R is not equal, so 1 plus minimum of both of this, that is 2. So as we can see, minimum number of changes required to convert MAR into RAM is 2. Okay, now as we can see, this can be done. See, simply convert this M to R and simply convert this R to M. So minimum 2 changes are required to convert this string into this string. Okay, so effectively we are taking O of Mn space in this case. Okay, and the time complexity is also O of Mn, because effectively we are going through each block of this memo map which we have taken to solve a question. Okay, so now let's simply jump to the coding part of this. As we can see here, we have passed 2 string as an argument to our dynamic approach. Okay, these are the base cases which we need to handle. The first one is, if our first string is empty, then what we gonna do is, the minimum number of changes required is to just insert that many characters which are present in the second string. So we are simply returning second plus length, second of length. Okay, then the second base case is, if the second string is also empty, then simply return the length of the first string, because that many character we need to delete to convert this first string into second string. Okay, now after that, this is the map which we have taken to store our values. Okay, which we have computed earlier. Now we are initializing this particular row and this particular column of our matrix, because these are the base cases which we need to handle. These are the things which we have handled. Okay, after that we are going in our string one by one. Okay, so we are going from first index to first length to the last length of both the string, and after that we are checking if the character present at that particular index of both the string are same or not. If it is same, we simply take the diagonal value. Okay, here is the case of the diagonal, and if it is not equal, then we are simply adding 1 to the minimum which we get from 3 adjacent values. Okay, because this value shows replacement, this value shows deletion, and this value shows insertion. So by doing that, we completed the dynamic approach of solving this question. So this is basically, let me write it down, deletion, this is basically insertion, and this is replacement. Okay, and after that, this will contain, the last block of our memo will contain the value which need to be returned, or the minimum number of changes required to convert the first string into second string. Okay, so this will contain that, and after that we return it to the main function. So now let's quickly look at the main function, what we have called out, what we have passed in the main function. We have to simply call the dynamic approach method with the first and the second string. Okay, now let's quickly compile this. Let me comment out this section, and now you can see that how quickly it will going to execute because we have used the dynamic approach. See how quickly it will give the result. So this is the advantage of dynamic approach. So in this case, let's now discuss the complexity of both the codes. So here time and space complexity is O of mn, where m is the size of the first string and n is the size of the second string. Likewise, space complexity is also O of mn. So that's how we are going to solve this edit distance problem. Hope you enjoyed it. Let's see you in the next tutorial.